Hello students. Today we are going to start with the topic trigonometrical identities. But before starting with the topic, let us discuss the various objectives of this topic. The first objective is using identities to solve or prove simple algebraic trigonometric expressions. Number 2, relations between different trigonometric ratios. But before starting with the topic, let us discuss some important points related to solving the trigonometrical identities. So the important thing that you all need to remember is that in order to prove a trigonometrical identities, start with any side. That is, either you can start with left hand side or you can start from right hand side. And by applying trigonometrical relations, reach to the other side. That is, if you start with the left hand side, reach to the right hand side. And if you start with right hand side, reach to the left hand side. In general, always remember this thing, that in general, start with the more complicated side. Students, always remember that we are always going to start with the more complicated side. Now, sometimes both the sides are complicated. In this situations, both the sides may be taken and reduced independently to the same result. Sometimes in the question it may be like that you have both the sides which are complicated. So in this situation, we are going to solve both the sides independently and we are going to reach up to some same result. Now let us discuss some relations between different t ratios which are going to be useful for you for solving each and every sum. So relations between different t ratios. The first one is that sine theta is equal to 1 upon cosecant theta, or cosecant theta will be equal to 1 upon sine theta. Number 2 is cos theta is equal to 1 upon secant theta, or secant theta will be equal to 1 upon cos theta. And tan theta is equal to sine theta upon cos theta, or we can say that sine theta upon cos theta will be equal to tan theta. And cos theta upon sine theta is equal to cot theta. And tan and cot, they are the reciprocal of each other. So that is tan theta will be equal to 1 upon cot theta, or cot theta will be equal to 1 upon tan theta. Students, you are going to remember 3 different identities which are going to be helpful for you while solving the sums based on trigonometrical identities. The first identity is sine square theta plus cos square theta will be equal to 1. Now from here we can also derive that sine square theta or any given angle, that is A, will be equal to 1 minus cos square A, that is by doing shifting only. Or cos square A will be equal to 1 minus sine square A. The second identity is 1 plus tan square A will be equal to secant square A. So on shifting we get secant square A minus tan square A will be equal to 1. And if we shift 1 to this side, it will become secant square A minus 1 is equal to tan square A. The last one is 1 plus cot square A is equal to cosecant square A. And if we shift 1 to this side, it will become cosecant square A minus 1 is equal to cot square A. Or if we shift cot square A to this side, it will become cosecant square A minus cot square A is equal to 1. But these are the 3 main identities that we need to remember. So I'll repeat it again. The first one is sine square theta plus cos square theta is equal to 1. 1 plus tan square A is equal to secant square A, and 1 plus cot square A is equal to cosecant square A. Now students, let us discuss some sums based on this topic. The first example that we are going to discuss is secant A minus 1 upon secant A plus 1 is equal to 1 minus cos A upon 1 plus cos A. So we are going to solve the left hand side. So our left hand side is secant A minus 1 upon secant A plus 1. Students, now we know that secant A is equal to 1 upon cos A, or secant theta is equal to 1 upon cosecant theta. So now instead of secant A, we are going to write 1 upon cos A. So on substituting, we get 1 upon cos A minus 1 upon 1 upon cos A plus 1. Now we are going to take LCM in the numerator also and in the denominator also. So on taking LCM, we get 1 minus cos A upon cos A upon 1 plus cos A upon cos A. Now cos A and cos A in the numerator and denominator will get cancelled out. So after cancelling out, we get 1 minus cos A upon 1 plus cos A, which is equal to RHS. So in this way, we are going to prove the trigonometrical identities. So let us discuss some more example based on solving the trigonometrical identities. The second example that we are going to discuss is prove that tan A minus cot A equal to 1 minus 2 cos square A upon sin A cos A. So in this example also, we are going to solve the left hand side. So left hand side is equal to tan A minus cot A. So now we know that tan A is equal to sin A upon cos A, and cot A is equal to cos A upon sin A. So we are going to write, instead of tan A, we'll write sin A upon cos A, and instead of cot A, we'll write cos A upon sin A. So now we are going to take the LCM. So the LCM of cos A and sin A will be cos A sin A. So on taking LCM, we'll get sin A into sin A minus cos A into cos A upon cos A sin A. Now sin A into sin A is sin square A minus cos A into cos A is cos square A. So we'll get sin square A minus cos square A upon cos A sin A. Now students, we can see that the result that we need in the denominator, we need sin A and cos A, that we have already got. Sin A and cos A we have got. But in the numerator, we don't need sin square A. Instead of sin square A, we need the answer in terms of cos square A only. Now we have already done the relation between sin square A and cos square A, that we have done that sin square A plus cos square A is equal to 1. So from there we have got the value of sin square A as 1 minus cos square A. So instead of sin square A, we are going to write 1 minus cos square A minus cos square A as it is upon cos A sin A. So minus cos square A and minus cos square A will become minus 2 cos square A. So this will come out to be as 1 minus 2 cos square A upon cos A sin A. So which is equal to 1 minus 2 cos square A upon sin A into cos A, which is equal to the right hand side. The third example is square root of 1 minus sin A upon 1 plus sin A is equal to cos A upon 1 plus sin A. Now students, in this example, the complicated side is the left hand side because it's containing a sign of under root. So we are going to start with the left hand side. So left hand side is equal to square root of 1 minus sin A upon 1 plus sin A. Now students, as we see in the sum that the denominator of the left hand side and the right hand side, they both are same. So we don't want to change the denominator. We just want to change the numerator. So for doing that, we are going to multiply and divide with the denominator only. We are going to multiply and divide the given statement with the denominator so that we are not going to change the denominator. So on multiplying and divide with the denominator, that is 1 plus sine A, will get square root of 1 minus sine A upon 1 plus sine A into 1 plus sine A upon 1 plus sine A. Now it is A minus B into A plus B in the numerator, which is equal to A square minus B square. So it will become square root of 1 square minus sine A whole square. And in denominator, it will become A plus B whole square. That is 1 plus sine A whole square. Now the square of 1 is 1 only, and the square of sine A is sine square A. So this will become square root of 1 minus sine square A upon 1 plus sine A whole square. Now what is 1 minus sine square A equal to? It is equal to cos square A. So the statement will be rewritten as square root of cos square A upon 1 plus sine A whole square. Now students, we are going to take this square common from the numerator and the denominator. So on taking square common, we'll get square root of cos A upon 1 plus sine A whole square. Now this square and square root will get cancel out. So on cancelling out, we get cos A upon 1 plus sine A, which is equal to right hand side. The next example is prove that square root of 1 minus cos A upon 1 plus cos A is equal to cosecant A minus cot A. Now students, in this example, the denominators of the left hand side and the right hand side, they are not same. So in this example, we are not going to do the step of multiply and divide with the denominator. Instead, in this sum, we are going to do the rationalization of the denominator. So we are going to solve the left hand side. So the left hand side is square root of 1 minus cos A upon 1 plus cos A. Now to rationalize the denominator, we need to have the rationalizing factor. So the denominator is 1 plus cos A. So its rationalizing factor will be 1 minus cos A. So on rationalizing, we get square root of 1 minus cos A upon 1 plus cos A into 1 minus cos A upon 1 minus cos A. In the numerator, it will become A minus B whole square. And in denominator, it is the identity of A plus B into A minus B, which is equal to A square minus B square. So on applying this, we get 1 minus cos A whole square upon 1 square minus cos square. So the numerator will be written as it is and the denominator will become 1 minus cos square A. Now what is 1 minus cos square A equal to? So 1 minus cos square A is equal to sine square A. So now we are going to rewrite the statement as 1 minus cos A whole square upon sine square A whole under root. So now we are going to take the square from the numerator and denominator common. So on taking out the square common, we'll get square root of 1 minus cos A upon sine A whole square. Now this square and this square root will get cancelled out. So on cancelling out the square and square root, we get 1 minus cos A upon sine A. Now we are going to write down these terms separately to get the final answer. So 1 minus cos A upon sine A will be written separately as 1 upon sine A minus cos A upon sine A. Now 1A is equal to cosecant A and cos A upon sine A is equal to cot A. So we got the final answer as cosecant A minus cot A, which is equal to the right hand side. The last example that we are going to discuss is prove that sine A plus cosecant A whole square plus cos A plus secant A whole square is equal to 7 plus tan square A plus cot square A. Now students, in this example also, the complicated side is the left hand side only. So we are going to solve the left hand side. So left hand side is equal to sine A plus cosecant A whole square plus cos A plus secant A whole square. Now students, in this example, the first step is that we are going to apply the identity of A plus B whole square in both the brackets. So on applying the identity of A plus B whole square, we'll get sine square A plus cosecant square A plus 2 sine A into cosecant A plus cos square A plus secant square A plus 2 cos A into secant A. Now sine square A and cos square A, they both have an identity related to them. So we are going to write them together. That will be sine square A plus cos square A plus 2 sine A into cosecant A plus secant square A plus cosecant square A plus 2 cos A secant A. Now, what is sine square A plus cos square A equal to? Sine square A plus cos square A is equal to 1. So we'll write, instead of sine square A plus cos square A, we'll write 1. Now, sine A and cosecant A, they are the reciprocal of each other. So instead of cosecant A, we'll write 1 upon sine A. So this will become plus 2 into sine A into 1 upon sine A. And sine A and sine A will get cancelled out. Plus secant square A as it is and plus cosecant square A as it is. And cos A and secant A, they are the reciprocal of each other. So we are going to write, instead of secant A, we'll write 1 upon cos A. And cos A will get cancelled out. So now we are left with 1 plus 2 plus 1 plus 2 and secant square A plus cosecant square A. But in the answer, if we see that we don't need secant square A and cosecant square A, but instead of secant square A and cosecant square A, we need tan square A and cot square A. Now students, secant square A has a relationship with tan square A that we have already done. That secant square A is equal to 1 plus tan square A. And cosecant square A is equal to 1 plus cot square A. So instead of secant square A, we'll write 1 plus tan square A. And instead of cosecant square A, we'll write 1 plus cot square A. So on rewriting, we'll get 1 plus 2 plus 1 plus tan square A plus 1 plus cot square A plus 2. So which will give us the final answer as 7 plus tan square A plus cot square A, which will be equal to the right hand side. Now students, you all will be clear that how to solve the sums based on trigonometrical identities. I'll give you one more rule to remember, that always while solving the trigonometrical identities, try to convert each and every given t ratio in the form of sine and cosine, because they are going to make your sum much simpler. So now you all will be able to solve the sums on trigonometrical identities. So solve those sums. Thank you and have a nice day.